Okay, so the last talk of the first session is given by Robert Strandh, of course, from the University of Bordeaux, and he is talking about the common Lisp object system in detail of a protocol for editor buffers. So,
thank you. So I should give you some context first. A long time ago, I wrote an editor called Climax. And of course, it kind of works, but I wanted to improve it. So I started a project a couple of years back that I call Second Climax. And then I realized a couple of months ago that I have too many projects to finish in my lifetime. So instead of trying to finish big projects that probably won't get finished, I decided to start breaking out pieces of code from existing projects. So this is actually the result of breaking out the buffer code from Second Climax. Okay? And as a result, you have something that's more reusable, more maintainable, and so forth, because it's not specific to that project anymore. So an editor buffer can be thought of as an editable sequence of items. And that might sound like a trivial problem, but the thing is that if you use the results from complexity theory, you will notice that the asymptotic worst case, the best result in terms of asymptotic worst case behavior is unacceptable for an editor, because it would use some kind of tree, and the overhead of the nodes of the tree would be so great that a character would need 20 bytes for its representation. And you would also have a log n complexity to insert or delete an item. So we can do better if we ignore the worst case behavior, because an editor has use cases that you can exploit, and that's basically what this is doing. So what in the existing editor technology that I've seen, basically two different techniques are used. And the first one is called gap buffer, and the second one is what I call line-oriented, and I'll describe those briefly. So the gap buffer representation of an editor buffer is basically storing the items in a vector. And this vector has three parts to it: prefix, a gap, and a suffix. Each of those can be empty. But the idea is that you make sure that the gap is located, that when you make a modification to the buffer, you make it either at the beginning of the gap or the end of the gap. And should the gap be positioned the wrong way, you just move objects so that the gap becomes positioned correctly. And what I call the line-oriented representation is you basically view the editor buffer as a two-level editable sequence. That is, at the upper level, you have an editable sequence of lines, and each line is an editable sequence of items. And then, of course, there's variation on how you represent the upper level and how you represent the lower level. And in particular, because a line is typically longer than just a few items, you can now use a more traditional representation on the outer level, such as a tree, because the overhead will be less, given that each leaf of the tree is now larger than it would be if you had a single item. And if you look at what exists, GNU Emacs and also Climax both use a gap buffer for the entire editor buffer. Many other editors use the line-oriented version, but with concrete exposure of the outer sequence. So it's not an abstract sequence. It's typically a doubly linked list, with the disadvantages that it has to expose these kind of details. And of course, there are exceptions, such as Vim, which I think was designed so that it would have disk-backed memory. They kind of assumed that you couldn't store the entire buffer in RAM. So they have a special structure that makes it easy to store and restore from disk. Okay, so when I designed this new protocol, I realized that there are basically two loops of operation in a text editor, and these loops are executed at a different frequency. So I call them the slow loop and the fast loop. The slow loop is triggered typically by a keystroke. That is, you type a character, something happens to the buffer, and then the entire thing gets redisplayed. It is slow because it's usually limited to typing speed. In the worst case, it's a little bit faster than that, in that you can move a mouse or resize a window, but it's still very reasonable. It's uses milliseconds for each iteration. So you can afford to redraw the entire screen for each iteration in the slow loop. Absolutely no problem. That didn't used to be the case. Both Multics Emacs and GNU Emacs go to great length, or it did, to minimize the recomputation of what you see on the screen in terms of editing operations on a DEC terminal. Okay? We don't need that anymore. We can afford to redraw the entire thing at the iteration of the slow loop. The fast loop, that's very different. Each iteration of the fast loop is an elementary operation, such as moving the cursor, inserting an item, deleting an item. Why is that faster? Because you might have a single operation on the outer level that triggers a host of operations at the inner level. Now, the typical case for that is, of course, you delete a region, and that region has hundreds or thousands of items in it. Okay? So the way I would like to implement that is as an iteration that says delete each item individually, because that's the easy way to implement it. You could do it more efficiently by having a more complex operation that could operate on regions. But there is still one case where you cannot easily obtain that. It's keyboard macros. You cannot prevent somebody from writing a keyboard macro that triggers 1,000 individual editing operations. So you still have a case where the inner loop is going to be executed much faster, or more iterations. Okay? And I wanted to exploit these two different frequencies and see if I could keep the structure of the entire protocol simple and still obtain reasonable performance. So again, the slow loop is sufficiently slow that you can just redraw everything each time. It doesn't really matter in terms of performance. And what characterizes this loop is that the view must determine what has changed in the buffer between two consecutive redisplay times. And that might not be at the occurrence of typing speed, because it could be that a view is hidden for an arbitrary amount of time, and then it's brought to display again, and so many editing operations might have happened since last time. I think I already said all this. Yeah, so the main motivation here is that for reasons of maintainability, I do not want to introduce special operations on multiple items at the lower level. I want to implement operations on regions as iterations of simpler operations. So the implementation that I'm describing here has two main protocols. The edit protocol corresponds to the fast loop. So it has operations for inserting, deleting individual items, moving cursors, and so forth. And the update protocol corresponds to the slow loop. The edit protocol is divided into two sub-protocols, the line edit protocol and the buffer edit protocol. corresponding exactly to this two-level sequence that I talked about before. And in my implementation, the two sub-protocols can be individually customized. And in fact, you can even substitute a different representation for the line and preserve the representation of the buffer level if you want. So the line edit protocol defines two classes, line and cursor, and several generic functions such as inserting, deleting items, querying item count, moving cursors, attaching and detaching cursors. The buffer edit protocol defines a single class called buffer and generic functions that operate on lines. In particular, you can join lines or split lines. The update protocol is probably the most interesting novelty of this approach. It defines a single function named update. And modifications to the buffer are marked by a timestamp. So there's no, well, let me take that later. When update is called, it passes the timestamp of the previous call to update. And a new timestamp is returned that says, okay, use this the next time you need to update your view. So a typical view says, some event happened, trigger some arbitrary modifications to the buffer, call update with the previous timestamp, return a new timestamp, repeat this. Okay? But it can go away for an arbitrary amount of time. Go away because the view is hidden, come back and say, now I want to be displayed again. I don't know what happened since. I just passed the old timestamp and I get back the modifications. And this update function is fairly complex. It has 6 parameters: the buffer, the timestamp of the previous call, and 4 functions that should be viewed as editing operations on the view. That is, presumably the view keeps some kind of sequence of lines that it displays. And these operations are called skip, modify, insert, and sync. Skip means the view keeps some kind of index into this sequence of lines. Skip means nothing has changed up till here. So you just skip so many lines. Nothing has happened since last time you called me. Modify means there's a single line. This has been modified. You need to change the way it's displayed. Insert means there's a new line that has been inserted since last time you called me. Here it is. And the last one, sync, I'm not going to talk about because I think it might actually not be needed. If I make a slight modification, it might go away. So the standard implementation, so much for the protocol. The standard implementation that I supply, the buffer is represented as a splay tree of lines. The splay tree is really nice because it's self-adjusting. What this means is that lines that are recently modified migrate towards the root of the tree. And this happens for several lines that could be far apart as well. So if you have 2 processes that update the buffer simultaneously, those the lines that are associated with those 2 processes will migrate close to the root, so that editing operations will be much faster in the future, automatically. The line I represent in 2 different ways, depending on whether it's open or closed. And a line is open if the last operation was an editing operation. The line is closed if the last operation was a query from the view saying, what is your contents? And an open line is represented as a gap buffer, a closed line as a simple vector. So in the absolute worst case, somebody types 1 character, inserting 1 character at a time. The line would be open, it'll be edited, and then the view comes and says, what's your contents? And it'll be closed again. So at the slow loop, there'll be a lot of work being done, but that is relatively rare, so it doesn't really matter. Where it does matter is when you execute a keyboard macro, because then you will have potentially hundreds or thousands of operations on the open line for a single closed line. So, benefits. Well, the main motivation was simplicity of editing operations. I don't have any need to create separate operations on regions or a complex product. I can just iterate the simple operations on it. The benefits of using generic functions is that you can customize all the protocols to your liking. You can add, before methods and other auxiliary methods to spy on what's really going on inside the protocol. Sophisticated users can supply their own implementations. So, for instance, at the moment, I allow any item in a line, but if you want the close operation, for instance, to check whether you have only ASCII characters in it, and in that case return a simple string, you can do that. It can be customized like that. I don't supply that possibility, but you can certainly customize it. A number of the operations that I supply, for instance, moving a cursor forward, is actually defined in terms of getting the position of the cursor, incrementing that position, and then storing that position in the cursor. If you're not happy with that implementation, that behavior can be overridden. It's just in there by default. Another benefit is that views are updated only when needed. There's no communication from the buffer code to the view. There's no observer that says, something was modified here, you better update yourself. The only communication here is from the view to the buffer saying, somebody just did something here, could you please compute a new view for me? So again, if a view is hidden, for instance, there's absolutely no activity going on. In the future, I'm working on an Emacs compatibility layer because this is line-oriented. So Emacs, being a gap buffer, also considers a new line to be just another character. So if your cursor is positioned on a new line and you delete it, then GNU Emacs doesn't have to do anything particular. Here, I have to merge two lines. And vice versa. If I insert a new line, I have to actually translate that into splitting two lines. The main motivation for this work is, of course, to create an editor for Common Lisp. And I'm working on an incremental Common Lisp parser that is going to be a lot better than the one that Climax uses, which is already better than the one GNU Emacs uses. This one is going to use a modified version of the Lisp read function. And I know how to make that incremental given this buffer representation. Currently, the operations are not thread safe. The main difficulty here is to avoid locking the entire buffer. I mean, that's easy to do. Lock the entire buffer whenever you do an editing operation. I would like to avoid that. So it's going to be a little bit more complicated because I need to find out whether it's enough to lock a single line, for instance. And that's going to take a little bit of thinking, but in theory, it shouldn't be terribly hard. And that's it. I'd like to thank the following people who read the initial versions of the paper. And if you have any questions. Excuse me, somebody gave me a terrible cold the other day.
Okay, maybe just start with the first question.
So, it avoided the presentation of saying that the buffer stores characters. So if I understand correctly, the buffer stores any kind of object.
Say that again?
The buffer stores any kind of object.
Yes.
It doesn't have to store like only characters.
Correct.
So if I want to, like, say, make a view that can display images, I can put images in the buffer.
Sure. I have absolutely no opinion about what you're putting inside the buffer, but because some people might consider that to be too much overhead. This is why the customization will allow you to do something else. If you want to restrict your lines to characters, you can do that. Yes.
Yes, I'm curious. Emacs was an effort to move away from line-oriented.
From?
Emacs was originally an effort to move away from line-oriented. And, I mean, Stallman was updating Tico when he wrote Emacs. So, my question is, why is your element line rather than S expression?
Well, you have to distinguish between two interpretations of line-oriented. There is nothing line-oriented about the way this is presented to the end user if you have this compatibility layer, whatever emulation layer you want. When Emacs went away from line-oriented, it was that aspect of things. That is, the user should not be thinking about the editing as being of lines. But you can stick any emulation layer in between the two, make the other one look like the first one, and so forth. So, and the reason I have line-oriented here, and many other editors, in fact, most other editors, is that it's more efficient in terms of performance, and it's much easier to associate parsing information and so forth with different pieces of the buffer. And so all of that is completely hidden to the end user, so it doesn't actually affect the editing experience at all.
Okay.
Yes?
About the previous question that was asked just a moment ago. In your implementation, could I possibly, like, for example, when I'm writing English text, then a line could be just a paragraph or something. When I'm writing Lisp, could I modify your implementation so a single line holds indeed perhaps a single expression, or when I'm writing, I don't know, perhaps Python, it could hold a single function definition?
Yes. I mean, like I said, it doesn't have any particular interpretation of what a line is. So just think of it as a two-level editable sequence. It's an editable sequence containing editable sequences. The way you then want to show those sequences is entirely up to you. The view must be programmed, for instance, be entirely reasonable to have a single line in here represent a paragraph of a word processor. That would be absolutely no problem whatsoever. Yes?
From what you said previously, I suppose it might not be the best question, but are there any issues with Unicode support?
But what?
Are there any issues with Unicode support?
As far as I can tell, no. I mean, Unicode is problematic in its ways anyway because of the combination of different Unicode points representing a single character. But since I don't care whether you put in characters or any items, it is up to the view to interpret what a sequence of item means.
Right, so when there is a delete character operation, it has to know what kind of data is in the buffer. Right?
That's true. If you want to influence if you want to restrict the way you can insert and delete items in terms of Unicode characters, you have to check that yourself.
So
I do absolutely.
Taking care of that here.
I don't do anything related to that at all.
Any other questions? None. So, one. Sorry.
Maybe. So if I got it right, then the name of the line is actually a misnomer, so it's more a logical block or a section, because the line is probably dangerous because you associate it with creating new lines, but actually a logical thing.
Yeah, I suppose you're right. But like I said, this is these names are not supposed to be exposed to the end user anyway, and you probably want to have some kind of emulation layer in between anyway, whether you want to emulate Vim or you want to emulate GNU Emacs or something like that, and then you can choose whatever names you want for these entities. Yeah.
How would you extend it to emulate Firefox?
I haven't studied how Firefox works, but probably would start with using a paragraph of text in each line, because it formats each paragraph as you resize the window. Yes.
What does it? If you want to have lines that are output from other lines, like a notebook sort of format, is it?
Lines that are output from other lines. What does it mean?
Where, like like in Mathematica, where you can have an input box, you can type stuff in, and then there's output boxes that follow it. And if you update the input boxes, then the output boxes will also be updated.
I would not use this library for something that requires that much structure. Like if I were to write a word processor such as TechMax or something like that, I would probably choose a much more complex structure with more levels and more nesting possible. This is basically just 2 levels. So conceivably you could put items in my lines that are formula or something like that, but probably not. Yeah.
Do you know the next thing you're going to be able to break out from Climax into its own module?
Say that again?
This started off as like breaking out a piece of Climax interface.
Yeah.
Have you identified any other parts?
Yeah, the next part is the incremental common list parser. Yeah.
Another question. Since we are dropping more and more complex use cases for the protocol, and as a thought experiment, how we could implement a 3D editor in this protocol, and how can we implement an audio editor?
What editor?
3D model editor and audio editor.
Oh, yeah.
Complex use cases of the
Yes.
Any ideas on the origins?
Well, the score editor is well on its way. In fact, one of them already exists, but audio I don't know yet. Yeah.
There's this idea of multiple cursors in editors like Atom or Sublime. I wanted to ask what you're saying on that. Is it supported?
You can have as many cursors as you want. Yeah. The thing is, you don't need as many, because in Climax, I needed many cursors because I had to use a cursor to associate parsing information with. But here, it'd be more natural to associate the parsing information with the line.
Are there any other versions of this library for now, or is only Climax for smaller time?
Repeat again, sorry.
Are there any other except Climax clients of this library?
Yeah. In fact, Dave Murray wrote Vim, and Vim-like editor using it, or so he claims. I haven't seen it actually. Yeah. And that happened before I use it myself.
Okay, so no more questions. Then thanks to you.
Thank you very much.